Good day everyone. Definite integrals part 2. This is about properties of definite integrals. In this part, in this video, let us see a few properties. The first property, integral a to b f of x dx is equal to integral a to b f of t dt. Even I can say that is equal to integral a to b f of y dy. Actually, only the variable is changed. The limits will be same. The function will be same. Here you have the variable of integration x. Here you have the variable of integration t. This we will be using in some sums, in some steps when required. So, this is a general property which you should know. Coming to the second one, integral a to b f of x dx is equal to minus integral b to a f of x dx. This property we will be using when our lower limit is a bigger number and the upper limit is a smaller number. That time we can introduce a negation or we can remove a negation and then we will interchange the limits and write it. So these two properties, why I am saying in the beginning is, these two will form part of some sum at some step. So you should know these two, okay? The first one is changing the variable. The second one is changing the limits with a negation. That we use only when the upper limit is smaller and the lower limit is greater. Okay. Now, let us move on to the next property. Okay. Now, I have written two more properties. The third one, integral a to b f of x dx is equal to integral a to b f of a plus b minus x. That is, we are adding both the limits minus x dx. This, when I do some example sums, you will understand clearly. Coming to the fourth property, actually it is a simplification or a special case of the third property, I can say. That is when the a is 0 and here you have a. Okay. So, integral 0 to a f of x dx is equal to integral 0 to a f of a minus x. The same one, see, 0 plus a, that is a. So, this property a bit modified or a special case when the a is 0 and the b becomes a, you get integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. This is a very important property, I can say, because we will be using it in many types of sums. So, today we are going to concentrate only on this fourth property. Okay. Based on that, I will tell you for which kind of sums we will be using. Wherever I can identify, I will classify it and tell you. Otherwise also we will be using it in many sums. So this is the property we are going to concentrate. So today I have taught you four properties, right? The first two I told they are a bit general. So you will use it at some step whenever required. The third one and fourth one you can group together and read. So the fourth property is the one we are going to consider today. Okay. So let me give you few examples and few types where we will be using this property and how that sum will become easily integrable if we use this property. Okay. Now, I have given here three sums. There are some similarities in these three sums. Let me tell you what it is. See the limits in all the three sums. You are having 0 to pi by 2. Okay. You look at the denominator of the three sums. You are having a sine term and a cosine term. Here you have root sine x. Here you have root cos x. Sine power 5x, cos power 5x. Sine power 3 by 2x, cos power 3 by 2x. And in all the three, you have a plus sign in between. Okay. Look at the numerator. The numerator you have a cos x alone here. Here sine power 5x. Here cos power 3 by 2x. So now I can generalize it like this. When the limit is from 0 to pi by 2. Okay? When the denominator consists of a sin x function, it may be sin x, it may be sin power 5x, it may be sin power 3 by 2x, it may be root sin x, which is sin power half x, isn't it? Plus the cos power, the same thing. That is, if you have power half here, here power half, power 5, power 5, power 3 by 2, power 3 by 2. Okay? When you come to the numerator, it will contain either sine or cosine function of the same degree. Here it is sine power 5x. Here it is cos power 3 by 2x. Here it is root cos x. So, hope you understand how we are comparing the three sums. So, we can say they all belong to the one type or one model. You can have anything. Cos power 5 by 2x, here sin power 5 by 2x, here cos power 5 by 2x. Here sin power 7x, 7, 7. So that doesn't matter at all. But the degree of all these things, the exponent should be same. And in the denominator, you should have both sin and cos with a plus sign in between. In the numerator, you can have either sin or cos. Okay? Now, I will do one sum of this type and you do the other two, and even I will tell you what will be the answer for such type of sums. It's not any magic or anything. For all the three sums, the answer is going to be pi by 4. Here it is pi by 2, no? Pi by 2 by 2. So the answer will be pi by 4. If it is a multiple choice question, if at all, you can straight away write the answer is pi by 4. If it is like this. Anyway, let me tell you how to do, what are the steps and how we get it. Okay? So, I think I will take this sum and explain to you. So, you do the other two yourself. So, I will write now I is equal to integral 0 to pi by 2 cos power 3 by 2x by sin power 3 by 2x plus cos power 3 by 2x dx. Okay? Mark the given sum, that is I, as 1. Now we are going to use the property I told you. Okay? So let me write that property. Integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. We are going to use this property. Here in the place of a, what do you have here? Pi by 2. Okay? So now I will write again I is equal to integral 0 to pi by 2 cos power 3 by 2. In the place of x, I have to write now pi by 2 minus x, because the a is here pi by 2. Then coming to the denominator, sin power 3 by 2 pi by 2 minus x plus cos power 3 by 2 pi by 2 minus x dx, right? Wherever x is there, you are substituting pi by 2 minus x, which is the a minus x. Now you know sin pi by 2 minus x, that is sin 90 minus theta, is cos theta. Cos 90 minus theta is sin theta, isn't it? So now I will be getting here 0 to pi by 2. This numerator, that will now become sin power 3 by 2x. Then this sin part will become cos. This cos part will become sin by the same complementary angle formula. So here I will get cos power 3 by 2x plus sin power 3 by 2x dx. Let me call it as 2. So 1 is the sum given. 2 is after using the property and simplifying, what I get, that is 2. Okay? So in such type of sums, you add 1 and 2. That will be a common step you will be doing. Add 1 and 2. Here you have I, here you have I. So you will get now 2I is equal to integral 0 to pi by 2. See the denominator in both? They are same. Okay, because you have a common denominator, you can straight away add the numerators. So whichever order you write, whether sine first or cos first, that doesn't matter. So let me write the denominator. So sine power 3 by 2x plus cos power 3 by 2x. Then here the numerator is cos 3 by 2x. Here the numerator is sine 3 by 2x, then dx. What do you see now? The numerator and denominator are same. So they will get cut in all the sums. So now I will be getting, this is integral 0 to pi by 2, just a dx, or it is 1 into dx. If you integrate, you know you will be getting an x within the limits 0 to pi by 2. That will be pi by 2 minus 0, which is pi by 2. You have 2i here. So I will be pi by 2 by 2, which is pi by 4. This is what I told you. The answer will be pi by 4 for all the sums. Okay. Hope it is very clear. But just quickly I will tell you some important steps. First, write the given sum as I. Now check all the points I have already told you. Okay. So given sum I, mark it as 1. Write the property. Use it. So your denominator will remain the same, just the order will be changed. The numerator, if you have a sine function, you will get a cosine. If you have a cosine function, you will get a sine function. You add 1 and 2. You will get 2i. Then you will get the numerator and denominator equal. So naturally you will be getting just like this. And it is x within 0 to pi by 2. So pi by 2. 2i is pi by 2. So I is pi by 4. How do you find it? Very easy. Okay. So you do the other two sums. So whatever be the power, and if your sum satisfies the conditions I have already told you, you will get the same answer, pi by 4. Okay. Now let me take a different sum now. Now consider these two sums. Integral 0 to pi by 2 sine squared x dx. Integral 0 to pi by 2 cos squared x dx. Even though here there is no denominator and does not belong to the type which we saw before, here because of the property sine squared x plus cos squared x is equal to 1, that identity is there, no? Because of that, this sum also will fit into that category, and even here you will be getting the answer as pi by 4. Now here I will just do one sum in this, you do the other one. I will take I is equal to integral 0 to pi by 2 sine squared x dx. Mark it as 1. Now let us write that property. Integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. Okay. Even here it is 0 and pi by 2, remember. So now I will become integral 0 to pi by 2. Now sine squared pi by 2 minus x dx, that becomes now as cos squared x dx, because sine 90 minus theta is cos theta. Mark this as 2. Now add 1 and 2. Add 1 and 2. You will get 2i, that is equal to integral 0 to pi by 2. You have sine squared x there. You have cos squared x here. So now because of that property, sine squared x plus cos squared x is 1. You will be getting here integral 0 to pi by 2 just dx. Again it is x. Between the limits this one, you will get pi by 2, right? So 2i is pi by 2. So the I will be equal to pi by 4. So for these two sums, you can use this property and you will get the answer easily as pi by 4. Okay. Now let us see another type of sum we will see now. Now I have given 3 sums. Okay. First one, integral 0 to pi by 2. 2 power sin x. Denominator 2 power sin x plus 2 power cos x. Here that 2 doesn't matter at all. You can have 2 or 3, but it should be same everywhere. See here, you have a sin x here, you have a sin x here, you have a cos x here in the power. So here also when you use that property, what will happen? In the numerator, you will get 2 power cos x, correct? In the denominator, this will become 2 power cos x, this will become 2 power sin x. When you add the 1 and 2, you will get again 2i is equal to integral dx. So you are going to get that x within 0 to pi by 2. So 2i will be pi by 2, I will be pi by 4. Okay. So even if for this sum, because of the sin x cos x and that pi by 2, this also will fit into that category. Right. See here, these two are exactly, when you see it, no, they don't straight away look like this pattern. But if you do one step, you will understand this also comes and fits into that type which we discussed so far. Cot x you can write as cos x by sin x, correct? I will just show that part. That is, you can write this 0 to pi by 2 dx by 1 plus this will be cos x by sin x. Okay. Then when you take LCM in the denominator, this sin x will come here and now you will get sin x plus cos x. I think now it is the same pattern, isn't it? Because you have power 1 everywhere. You have sin and cos here, you have a sin here. So this sum. Here instead of cot x, you can even have tan x. 1 plus cot x, 1 plus tan x. Okay. Similarly this one. You have 1 plus root tan x. You can have 1 plus root cot x also. So here also what will happen? You will be getting dx by 1 plus, you can write it as root sin x by root cos x, right? Now take LCM. What will happen now? You will get 0 to pi by 2. This root cos x will come here. You will be getting here root cos x plus root sin, correct? So now do you understand all these three? They also belong to the type we discussed so far. So the answer for these also pi by 4. So don't imagine for all sums I am going to deal with hereafter everything the answer is pi by 4. Okay, it is not like that. Here the limit is 0 to pi by 2 and we are dealing with the sin x, cos x, etc. So it is coming pi by 2 by 2. Okay, that is pi by 4. So now I think the straight sums application of formula I have told. Now let us see. Yeah, bit more different from this we will see, but we are going to apply the same property. Okay. Now look at the two sums I have given. Integral 0 to pi. First of all, the pi by 2 thing is not there. Okay. Then I don't have sin x cos x like that. I have e power cos x. In the denominator, I have e power cos x plus e power minus cos x dx. Definitely the answer is not pi by 4 for two reasons. Okay. Then next one, integral 0 to 2 pi 1 plus 1 by 1 plus e power sin x dx. Okay. So a bit different from what we have worked so far, but we are going to use the same property. Let us see what is the use of that property in these two sums. Okay. So now let me take this sum first. Okay. So I is equal to integral 0 to pi e power cos x by e power cos x plus e power minus cos x dx. Now just think a bit. You have this limit as pi. What is cos of pi minus x? Cos 180 minus theta is minus cos theta. You know, in the second quadrant, cos is negative, right? Remember that concept. So, if we apply that property, you know, in the numerator, you will get a minus cos x. Here, you will get a minus cos x and it will become plus cos x. So, like that, you have to think and we have to make use of that property. Mark this as 1. Then, let us write that property. Integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. So now what is our a? A is pi. So now the I will become integral 0 to pi e power cos pi minus x by e power cos pi minus x plus e power minus cos pi minus x dx. Right? Now, cos pi minus x will become minus cos x. Here also I will get a minus cos x. Here already there is one minus, so that will become now plus cos x. Okay. So now I will write 0 to pi. This is e power minus cos x. This first term is e power minus cos x. The second term is e power cos x dx. Mark this as 2. Now as usual, add 1 and 2. Add 1 and 2. You will be getting a 2i here. Integral 0 to pi, right? Now see the denominator. A common denominator, right? So now let me write in the denominator e power cos x plus e power minus cos x. What is the numerator here? E power cos x. Into you have e power minus cos x. So here also they get cut. You get 1 into dx. So now you will get x. Now it is within the limit 0 to pi. So you will get pi. So now I is equal to pi by 2 is the answer. Actually the limit is pi. So 2i will be pi. So I is equal to pi by 2. Okay. So even though this is a bit different, but applying that formula we go into the same this thing, no? That is x alone we are getting when we integrate, and we get this as answer. Here also, even though in only one term you are having that sin x as a power in the exponential, if you use that property, what will happen? Sin 2 pi minus x will become e power minus sin x, isn't it? Let us see what happens. Now, I is equal to integral 0 to 2 pi 1 by 1 plus e power sin x dx. Mark it as 1. Now let us apply the property. Integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx, right? So now we will get I is equal to integral 0 to 2 pi 1 by 1 plus e power sin 2 pi minus x dx. That means I will be getting here 1 by 1 plus e power minus sin x dx. Right? Now, e power minus sin x I can write as 1 by e power sin x. Okay? So, now I am writing that as 0 to 2 pi 1 by 1 plus 1 by e power sin x dx. Take LCM here. That e power sin x will go to the numerator. So, we will get integral 0 to 2 pi e power sin x by e power sin x plus 1 dx. Mark this as 2. Add 1 and 2. Okay? Add 1 and 2. You will be getting 2i. See the denominator? It is the same thing, right? So, you will get integral 0 to 2 pi 1 plus e power sin x. Let us come to the numerator. You have a 1 here. You have a e power sin x here dx. Here also they get cut. So you get, if you integrate, you will get x within 0 to 2 pi. That will be equal to 2 pi. So I will be equal to 2 and 2 will go. I will be equal to pi here. So do you understand these sums? Now we have actually seen a bit different from each other. But everywhere we use that property. And the sum gets much simplified, and you get after integrating an x. Okay, so that depending upon the limit you get it, and 2i is there, you get I is equal to. Hope you have understood these basic sums in that property well. So in the next video, let me give you a few more types of the same sum and a bit different sums where I am going to use the same property. So first, in this video we are going to, the first property which you are learning is integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. That's very important. So that we are first learning in detail in which type of sums we will be using that property. Okay. Thanks for watching the video. Share it with your friends and classmates. Thanks once again.